All right. Next question. Last time we discussed numericals. So this is the next question. The following lines drawn represent reversible adiabatic processes for gases CH4 and CO. Which line corresponds to CO? This is the graph shown. Log P versus log V. P means pressure, V means volume. And you see two lines. One is line A and one is line B. One line corresponds to CH4 and one line corresponds to CO. We have to identify which line corresponds to CO. It is mentioned that the process is reversible adiabatic. For reversible adiabatic process, we know that P V to the power of gamma is equal to constant. Now the graph is plotted between log P and log V. Whatever is on the y-axis will be called y. Whatever is plotted along the x-axis will be called x for mathematical equations. So if I want to denote log P by y and log V by x, then I'll have to put y and x in the respective equation and then compare. Before that, I have to get or derive an equation in which I have both log V and log V present. We just know that P V to the power of gamma is constant. Let the constant be equal to k. You can take any random notation because it's a constant. So let it be k, let it be c. Taking log on both sides. If I take log on both sides, I'll get log P plus gamma log V is equal to log k. Now, as I said, I want to bring it to a form such that I can easily compare it with the equation of a line. So I have brought it to this form, the one that you see inside the box. So this is the form of the equation containing log P and log V. If I compare this equation with y is equal to mx plus c, because y equal to mx plus c also represents a straight line, then I can say that the slope is equal to minus gamma. How minus gamma? Look at the log v minus gamma log v, that term. So if I say log p is equal to y and log v is equal to x, then I can say m is equal to minus gamma and c, that is the intercept, is equal to log k. So minus gamma will be the slope of the line. How did I get that? Because I brought it to a form where y is log p and x is log v. So I brought it to that form and then I compared this with y equal to mx plus c. On comparing coefficients, we saw that m is minus gamma. Now we know that methane is a polyatomic gas because there are 5 atoms in one molecule of methane. CH4, 1 atom of carbon and 4 atoms of hydrogen. So gamma is 1.33 for a polyatomic gas, and carbon monoxide is a diatomic gas because you have 1 atom of carbon and 1 atom of oxygen. So it's a diatomic gas. For a diatomic gas, gamma is 1.4. How did I get this? Because Cp by Cv is gamma. I know that Cv is equal to, for a diatomic gas, Cv is equal to 5 by 2R. So Cp will be equal to Cv plus R, that is 7 by 2R, and then take the ratio of Cp and Cv will get 1.4. That is 7 by 2R by 5 by 2R. So gamma is 1.4 for a diatomic gas and gamma is 1.33 for a polyatomic gas. Now, If I look at the two lines, I can say that the slope of line A is more negative. The slope of line A is more negative than the slope of line B. That means line A must have a slope of minus 1.4 and line B must have a slope of minus 1.33. That means line A is corresponding to CO, that is carbon monoxide. If I look at the two lines, I'll figure out that line A has a more negative slope. Mathematically, if I have this, then if I have different lines, right, then I can say that this has the most negative slope, this line, and this has the least negative slope. More negative is minus 1.4 than minus 1.33. So A must correspond to carbon monoxide. The slope of line A is more negative than the slope of line B. So A must be for carbon monoxide. Okay. Next question. A gas is expanded reversibly from V1 to V2. That means it's an expansion. Final volume is V2, initial volume is V1. The internal energy of the gas is U, and U is given as a function of volume. That is, U is equal to alpha root V, where alpha is a constant and V is volume. Calculate work done by the gas. So U is internal energy, alpha is a constant, and capital V is volume. That means I can say that U is a function of volume. Gas is ideal. Now we know that if the gas is ideal, then U will be equal to NCVT. They have done formulae related to an ideal gas. In that list of formulae, U is equal to NCVT is given. So U is equal to NCVT is a formula for ideal gas, where U is the internal energy of the ideal gas, N is the number of moles of the ideal gas, CV is the molar heat capacity at constant volume, and capital T is the temperature of the gas. Also, it is given that U is equal to alpha root V in the question. So equate them. Alpha root V is equal to NCVT. I don't know whether the gas is monoatomic or diatomic or polyatomic. So I cannot substitute the value of CV as any particular value like 3/2R or 5/2R. I cannot do that because it is not given in the question whether the gas is monoatomic or diatomic. Now, CV, I know that Cp upon Cv is equal to gamma and Cp minus Cv is equal to R. On using these two equations, I can derive that Cv is equal to R upon gamma minus 1. So instead of writing Cv, I can also write R by gamma minus 1. Instead of writing Cv, I can write R by gamma minus 1. So that's what I did in this. I substituted the value of Cv as this R by gamma minus 1. Also, temperature is PV by NR because PV is equal to nRT. So temperature is PV upon NR. On solving this, I'll get P as this. Also, we know that work done is equal to minus PdV integral V1 to V2, where V1 is the initial volume and V2 is the final volume. The value of P has been put. Alpha is a constant, gamma minus 1 is also a constant. They can be taken outside the integral sign. So alpha, gamma minus 1 have been taken outside the integral sign. So I'm integrating only V to the power of minus half. This will be the expression if I'm integrating. How did I get this? We know that if this is the integral, then the value of this is x2 to the power of n plus 1 minus x1 to the power of n plus 1 upon n plus 1. So instead of x, I have v here. Instead of x, it is v here. And instead of n, it is minus half. The power of v is minus half. So I've used this same formula. You must know this formula. This is the fundamental formula of integration. And this will be required ahead also. So on putting the values, this is what I'll get. Now minus half plus 1 is plus half. So this is what I'll get. Minus half plus 1 is half. And anything to the power of half is nothing but square root of that. So finally, this is the value of work. But this is work. The question has specified something else. The question has asked me to calculate the value of work done by gas. This word is mentioned. Had they just mentioned calculate work done, I would have stopped here. I would have stopped here. Here I would have stopped. But they have specified that find out the work done by the gas. Since they have specified the word by the gas, I'll take a modulus. Work done by the gas is always modulus of work done. And the final answer is this. If I take modulus, this minus will go. This minus will go because I have taken modulus.
Sir,
Yes.
but if work is done by a gas, then shouldn't the total work be negative?
That is what I've done. Na? Work is negative only. Na? This is the value of work. Na? This is the value of work. So it's negative.
So why are we taking the mod?
Because question has said find out the work done by the gas. When they specify the word by the gas, you must take the modulus and then report the final answer.
But why do we take modulus?
Because they have specified that find out the work done by the gas. If they say by the gas or if they say on the gas, you have to report only the magnitude. That's the convention.
Okay.
Okay, sir.
But if they don't mention anything, then it is as it is along with the sign. That time don't take modulus. We will take modulus only if they mention the word by the gas. or they mention the word on the gas. If they don't mention anything by or on, we will report the value as it is without taking a modulus. Okay, next question. Now see, look at this question. Calculate work done. Now here, if you see, they have not mentioned by the gas or on the gas. They have just said calculate work done. So now we will not take modulus. They have just said calculate work done. So now we will not take modulus. So this is a question where adiabatic expansion of 1 mole of a gas is taking place against an external pressure of 1 atm. Assume the gas to be polyatomic. Okay. First of all, it is adiabatic. It is adiabatic. And if it is adiabatic, according to first law of thermodynamics, I can say that delta U is equal to Q plus W. So Q is 0 because it's adiabatic. So I'm left with delta U is equal to W. Another thing is they have mentioned initial pressure is 10 atm and initial temperature is 300 Kelvin. How do I know that it is initial? Look at this word from 10 atm and 300 Kelvin. That means initially the pressure was 10 atm and initially the temperature was 300 Kelvin. Whenever the word from is used, after from, whatever value is given, that corresponds to the initial value of the parameter. So initial value of pressure is 10 atm and initial value of temperature is 300 Kelvin. Now, next part of question. Against an external pressure of 1 atm. Against an external pressure of 1 atm, this against word means that external pressure is 1 atm and that is a constant value of pressure because they have just said that an external pressure of 1 atm is acting. That means the pressure is constant. It is 1 atm throughout the process of expansion. So whenever they say against an external pressure of some value, that means the external pressure is constant. We have learned earlier that if external pressure is constant, then the process is irreversible process. Because in any irreversible process, the external pressure is constant. चाहे वो expansion हो या compression हो. External pressure constant किस में होता है? Irreversible process में होता है. वो block वाला example जो दिया था मैंने first lecture में. So external pressure is constant in an irreversible process. This external pressure word indicates that the process is irreversible. Since the process is irreversible, we will use the formula for work done in an irreversible process, and that is equal to this formula. For any irreversible process, the work done is this minus P external multiplied by V2 minus V1. This is delta U. This is W. And this is delta U. Delta U is equal to W in an adiabatic process. Just now we proved this. Now initial pressure is 10 atm. Final pressure is the external pressure, that is 1 atm. Always remember the final pressure will be the external pressure in an irreversible process. But the values are given in atm, so I have converted to Pascal. 1 atm is 101,325 Pascal. So I have written P1 is equal to this much Pascal. And P2 is equal to this much Pascal. You have to use Pascal because Pascal is the SI unit of pressure. All values in this chapter must be in SI units. Put the equation, put the values in the equation. That is delta U is equal to W. If I put the values, This is what I'll get. Gas is polyatomic, so Cv is equal to 3R. For a polyatomic gas, Cv is 3R. We have learned in the second lecture.
Sir, we can
Yes.
find out T2 by using P1 by T1 is equal to P2 by T2.
How? That is only when the volume is constant. Here expansion is taking place. The volume is not constant, right?
Oh, right, sir.
We cannot use that formula. So volume is not constant because expansion is taking place. So if I use this formula, final value of pressure is 1 atm because that is the external pressure, and initial value of pressure is 10 atm because that is given, that from 10 atm. That means the initial pressure was 10 atm. I've converted atm to Pascal by multiplying by 101325. For a polyatomic gas, Cv is 3R. Also, as per ideal gas equation, V2 will be equal to nRT2 by P2 and V1 will be equal to nRT1 by P1. I've put that. So this is V2 and this is V1 because V2 is nRT2 by P2 and V1 will accordingly be nRT1 by P1. T2 is unknown because final temperature is not given. So I'll find out the value of final temperature like this. If I find out the value of final temperature, now I can easily calculate the value of work done. What is work done? Either you use this formula for work done, that is minus P external V2 minus V1, or you use this formula, that is mCv T2 minus T1. Both are equal because it's adiabatic. So any of the formulae can be used. Either you use mCv T2 minus T1, or you use minus P external V2 minus V1. I used mCv T2 minus T1. I put the values, and this is what I get. N is the number of moles. It is given in the question that there is 1 mole of gas. Cv is 3R for a polyatomic gas. R is 8.314 joule per mole Kelvin because I have to use SI units. On putting those values, finally I'll get the value as this minus 1683.6 joule. Since it's a large value, I've converted it to kilojoules. That will depend on your options. If options are in joules, you don't have to convert anything to kilojoules then. But if options are in kilojoules, you have to convert the value of joule to kilojoule. So this is the final answer. Now see, this minus sign is still there. Kindly do not take the modulus now. Why are we not taking the modulus? Because in the question, it is just written calculate work done. They have not mentioned by the gas or on the gas. So do not take modulus. Next question. A gas performs 3 kilojoule of work. A gas performs 3 kilojoule of work as it expands reversibly and adiabatically. Its temperature before expansion was 27 degrees Celsius. Value of Cv is given. Find the final temperature of the gas, but in degrees Celsius. Assume 1 mole of gas. So what is the process here? Process is again adiabatic expansion, and initial temperature was 27 degrees Celsius. Now remember, you can never use temperatures in degrees Celsius in any question. You have to use temperatures in Kelvin. So conversion is necessary. That means I can say that the initial value of temperature was 27 plus 273, 300 Kelvin. So this is what I can say. Work is done by the system because it is written that it's expansion. So the value of W will be negative in expansion as per convention. For expansion, work is negative. For compression, work is positive. 3 kilojoules of work. That means W is equal to minus 3 kilojoules.
Here, if work is done by the system, it won't be in the modulus.
Pardon?
You won't take the modulus here because work is
No,
done
no,
by
no.
the
Modulus अभी क्यों? Modulus तो final answer में लेना होता है ना. During the question नहीं. Modulus is always finally at the end of the question. I mean at the end of your answer. When you are solving questions, do not take modulus during that time. When you are finally reporting the answer, that time you have to take modulus in case they are asking by the gas or on the gas.
So we have to take the positive and negative sign accordingly.
Yes, that is while solving, but when you are writing the final answer, when the sum has ended, that time you can take the modulus if they're asking you to find out the work done by the gas or work done on the gas. But while you are solving a question, never take modulus. चाहे वो expansion हो या compression हो. When you are solving the question, you must solve the question by putting the appropriate sign of work. Do not take modulus while solving questions. So work is done here by the gas. Because work is done by the gas, W is equal to minus 3 kilojoules. But I have to use SI units. So I've converted kilojoules to joules. अभी मॉड्यूलस नहीं लेना है, सिर्फ W लिखा है ना, मॉड W नहीं लिखा है. When you're writing W, put the proper sign. For adiabatic process, delta U is equal to W is equal to NCV T2 minus T1 because delta U is equal to NCV T2 minus T1. W is given as minus 3000. So substitute the values. N is given as 1 mole. CV is given in the question as 20. T2 is unknown. T1 is given as 27 degrees Celsius. So I've taken 300 Kelvin. On solving this, the value of T2 will be in Kelvin. So T2 comes out to be 150 Kelvin. But the question has asked me to report the answer in degrees Celsius, and that is why I converted Kelvin to degrees Celsius back again. So the final answer is T2 is equal to minus 123 degrees Celsius. If your options are in degrees Celsius, finally you have to convert Kelvin to degrees Celsius. If options are in Kelvin, then keep the temperatures in Kelvin. Don't convert them. Because when you are solving any formula-based question, in that formula, you must put the value of temperature in Kelvin. You can never use any temperature in degrees Celsius while substituting the value of temperature in a formula. Always temperatures need to be in Kelvin. Irrespective of the formula, irrespective of the chapter, in chemistry, whenever you're using temperature, temperature has to be in Kelvin. Do not forget that. I have converted the temperature to degrees Celsius here because they asked me in the question to report the answer in degrees Celsius. See, they have mentioned what is the final temperature of the gas in degrees Celsius. That is why I converted. Okay. So we did numericals. Let's go to the next part. I have already sent the PDF of this. Day before yesterday, I sent the PDF of this entire thing, lecture, containing all the numericals and the solutions. Kindly note them down properly before Monday and submit before Monday. Next part, that is today's lecture. This also you have to write down and submit before Monday. Enthalpy. Capital H is called enthalpy. What is enthalpy? Enthalpy is heat. It is heat, but it is that heat when the pressure of the system is constant. So in general, we say everything heat. Whatever energy flows because of differences in temperatures, we call that energy heat. But if the heat is flowing at constant volume, we call it change in internal energy of the system. If the heat is flowing at constant pressure of the system, we call it change in enthalpy of the system. So enthalpy is H, capital H. Mathematically, enthalpy is defined as U plus PV, where P is pressure and V is volume. Capital U is the internal energy of the system. So H is equal to U plus PV is the definition mathematically. If I take derivatives on both sides, I'll get dH is equal to du plus pdv plus vdp. Now I told you if pressure of the system is constant, that means dp will be equal to 0. dp will be equal to 0 because pressure is constant. If dp is 0, this term goes and I'm left with dH is equal to du plus pdv. From the first law of thermodynamics, we already know that du is equal to dq plus dw. We know that du is equal to dq plus dw. This is the first law of thermodynamics in differential form. Now dw is nothing but minus pdv. So I can say this is the first law of thermodynamics. If pressure is constant, that means dq becomes equal to dh. How? See, this is dh, right? This is dh. And what is dq? From here, if I write, dq will be du plus pdv. So dH is same as dq if pressure is constant. dH is nothing but dq if pressure is constant. So if pressure is constant, I can say that dq is equal to dH or q is equal to delta H. If the gas is ideal, delta H is equal to mCp delta T, where capital Cp is the molar heat capacity at constant pressure. And in general, delta H is what? Just now I said that H is equal to U plus PV. Mathematically, the first expression is H is equal to U plus PV. So if I measure the enthalpies at two different conditions, under two different conditions of the system, so I can say that H2 will be equal to U2 plus P2 V2, where U2 is the final internal energy of the system, P2 is the final pressure of the system, V2 is the final volume of the system. So U2 plus P2 V2 will be the final value of enthalpy. Initial value of enthalpy is U1 plus P1 V1, because 1 means initial and 2 means final. So putting the values, I can get that delta H is equal to delta U. Why delta U? This U2 minus U1 will be delta U. Whatever is delta means final minus initial. So U2 minus U1 will be delta U. And I'm left with P2 V2 minus P1 V1. So I can also write like this, that is delta H is equal to delta U plus P2 V2 minus P1 V1.
So can we write delta PV then?
Yes, you can write delta PV also, right? But if values of pressure and volume are given, then you will have to write P2 V2 minus P1 V1. So delta PV is nothing but this thing, this quantity, P2 V2 minus P1 V1. This is what delta PV.
But are we assuming the pressure to be constant?
So if pressure is constant, then the value of Q will be same as delta H. That is a different thing. Here pressure may not be constant, may be constant. I'm talking about enthalpy now. I'm not talking about heat. I'm talking only about enthalpy now.
Sir, can you scroll up a little bit?
Yes. Even if pressure is not constant, delta H can be calculated in this way. That is what I'm trying to say. But in that case, don't say that delta H is equal to Q. If pressure is constant, then only we'll say that delta H is equal to Q. If pressure is not constant, then we will just say that Q is heat and delta H is enthalpy. Then they two are two different things.
Sir, here why have you written minus PdV?
Work done, na? dW is minus PdV. Formula for dW is equal to minus PdV. This is a value, no?
Oh, okay.
That is why if you integrate on both sides, you get W is equal to minus PdV.
Okay, sir.
Okay. So if pressure is not constant, let's say, that time you have to use this formula of delta H. So if pressure is constant, then I can say that Q is equal to delta H. If pressure is not constant, then Q is not equal to delta H. Now, if a chemical reaction is taking place, at constant pressure and constant temperature, then let's see how we find out the value of delta H. This becomes the formula of delta H in that case. How did I get this? Look at this expression. Delta H is equal to delta U plus P2 V2 minus P1 V1. Now, if I consider gases present in my reaction, then P2 will be the pressure of the system of gases after the reaction is over. Similarly, V2 will be the total volume of gases after the reaction is over. So I can say that P2 and V2 correspond to the states of the products, because after reaction is over, you will get products. So P2 is pressure of products, V2 is volume of products. P1 is pressure of reactants, V1 is volume of reactants. Using ideal gas equation now, I can say that P2 V2 is equal to N2RT. I'm not writing T2 or T1 because temperature is constant. If a reaction has started, it will take place at the same temperature.
Pressure is also constant, so you need not write P2.
Yeah. I'm just saying. So that is how. Then similarly, P1 V1 is equal to N1 RT. But if the pressure of the system is constant, if the reaction is taking place at a constant pressure, let's say in an open container or in an open vessel, then P2 is same as P1. So I can just write P. If a system is open, like an open vessel or an open reaction tank, that means the pressure acting is just the ambient pressure. So it's a constant pressure system. So the pressure acting on the reaction is constant. That means the reaction is taking place at constant pressure. So I'll write just P. But the volume is different because different gases are involved in the reaction, and based on the different gases, the volume will change. N2 is the number of moles of the products, N1 is the number of moles of the reactants, considering gases only, because these equations are applied for gases now. Now, if I say PV2 minus PV1, I will get N2 minus N1 RT. This N2 minus N1 is called delta Ng.
So why not delta N?
Yeah, why not delta N? That G indicates that we are considering only gases present in the reaction, which means that if I have a solid component or a liquid component, I will ignore it. I will not take it into consideration for calculating delta N. So for calculating delta Ng, I just need to look at the gaseous components present in my entire reaction. Please remember this. That is why we write delta Ng. We don't consider the solids and liquids present. Now, why like that? Because the volume of a solid changes by a very small amount. Similarly, the volume of a liquid changes by a very small amount. So if you see the change in volumes of gases, the change in volumes of gases is very large. But the change in volume of solid in a reaction is very small. Similarly, the change in volume of a liquid in a reaction is very small. So we can safely ignore the changes in volume occurring due to the presence of solids and liquids in the reaction. We will just focus on the changes occurring due to the gaseous components present. That is why we write delta Ng, we don't write delta N. G means gases. If I want to ask you, what is the value of delta Ng for this reaction? Tell me the value of delta Ng now. If I tell you what is the value of delta Ng for this reaction, what is the value of delta Ng for this reaction?
2.
What is the value of delta Ng for this reaction?
2.
What is delta Ng? N2 minus N1. Number of moles of products. 2 is the number of moles of products. That is this one. Minus. Delta is always what? Minus, right? Minus component will be there. Minus moles of reactants. So 1 plus 3. So the value of delta Ng is -2. For this reaction, the value of delta Ng will be -2. Next, if I ask you what is the value of delta Ng for this reaction,
So it would be 0.
what is the value of delta Ng for this reaction? How many gaseous components are present in this reaction?
-1.
How many gaseous components are present in this reaction?
Only one.
Only one, that is carbon dioxide, which is in the product side. So if I look at the coefficient of carbon dioxide, it is 1. So 1 minus, look at components on the left hand side of the reaction. You have a solid component, calcium carbonate is a solid, but I need only gas. That means I don't have any gas on the reactant side of the reaction, so I cannot write anything here. So 1 minus 0, which is 1. So delta Ng is 1 for this reaction. Any doubt? Okay, delta Ng is clear. So you will only look at gases present on products as well as reactant side. So this is how I get this formula. This formula has to be learned by heart. So I wrote delta Ng, the meaning I explained to you just now. Now, sometimes in the questions they ask you whether delta H is more than delta U or delta H is less than delta U. So simple mathematics. If I say delta H minus delta U, I'll get delta Ng RT from this equation. Now R is always a positive value. Temperature in Kelvin also is always a positive value. That means this will just depend on the sign of delta Ng. So if delta Ng is negative, that means this quantity is negative, and I can say this. Negative means less than 0. On solving this, I'll get delta H less than delta U. Similarly, if delta Ng is positive, then delta H will be more than delta U. That's what is mentioned here. If delta H is positive, reaction is endothermic. If delta H is negative, reaction is exothermic. Very, very important points. We will use this again later in the last 2-3 lectures. But now you should know that if delta H is positive, reaction is endothermic. If delta H is negative, reaction is exothermic. What is an exothermic reaction? Energy is released. Energy is released. So delta H is negative, that means reaction is exothermic. Energy will be released to the surroundings. And fifth point I told you, solids and liquids are ignored because there is no appreciable change in the volumes of solids and liquids. So delta V is taken as 0 for solids and liquids. So we don't use any solid or liquid for calculation of delta V or delta G, because the volume of any solid changes by a negligible amount. Similarly, the volume of any liquid also changes by a small amount. So we can ignore it for calculations. Now there are two things, there are two types of calorimeter. Now in NCRT, this is not there. Constant pressure calorimeter or coffee cup calorimeter is not given. But the second type of calorimeter is given. That is bomb calorimeter. This is given. Questions are usually based on bomb calorimeter in the exams. But yes, you should know the meaning of coffee cup calorimeter also. And I gave this. Don't worry about the construction. Nobody is going to ask you the construction of calorimeter. I have written so that you can just have a look at it. But nobody is going to ask you any question related to the construction or the materials used to construct the calorimeters. So you can safely ignore this part. But what you cannot ignore is the mathematical portion. This from here you cannot ignore. Heat released by reaction is equal to heat gained by solution. This is the principle of calorimetry. They can ask you, what is the principle of calorimetry? You will say heat released by reaction is equal to heat gained by a solution. What happens here, I tell you. This is a system. You have a solution which could be a reaction mixture, like let's say a neutralization reaction is taking place in this solution. Let's say HCl and NaOH are reacting with each other to form NaCl and water. So HCl and NaOH have been added to water, and this entire mixture which you see is called a reaction mixture. The reaction mixture contains water, acid and base, and then they react to form salt and water. And there is a stirrer. This stirrer is used for agitating the liquid, because if you stir, then uniformity is maintained. After you stir a solution, the solution is uniform in concentration. So you stir, you keep stirring the solution. Okay. So once it is stirred, the heat is also uniformly distributed throughout the solution. Now, because of this reaction, temperature will rise, and that temperature rise is recorded with the help of a thermometer. Why is this called a constant pressure calorimeter? Because it is just atmospheric pressure or the ambient pressure. See, the liquid is filled till this point. This is the liquid. Okay, this is the liquid. Liquid containing the reactants. And above it is empty. So this is nothing but atmospheric pressure, right? So this is just, this portion is empty. Liquid is filled till here. This is the liquid. Right, till here you have the liquid. So above the liquid it is empty, and that is why we are calling it ambient pressure. So it's a constant pressure calorimeter. The pressure is constant because it is ambient pressure acting on the reaction. This is a liquid. This liquid is nothing but it contains the reactants and products formed. Okay. The thermometer is used to see the change in temperatures. So when you start the reaction, you see the temperature of the solution. I mean, before you start the reaction, you see the temperature of the solution. Maybe it is at room temperature, so it will maybe show you some 35 to 40 degrees Celsius. After you have agitated the mixture, after you have stirred the reactants and waited for some time, you will see a rise in temperature. So after you have waited for the reaction to get over, you will see a rise in temperature shown by the thermometer. And once the temperature is steady, that means once there is no further rise, that means the reaction is over. So you will record the final temperature. You knew the initial temperature. You know whatever is present inside the liquid, that is how many moles of acid, how many moles of base, all those things you will know because you only have added. And then you will use this. Heat released by reaction is equal to heat gained by solution. Okay. So it's basically heat lost is equal to heat gained. Who is losing the heat? The reaction is losing the heat if the reaction is exothermic. Heat will be released by the reaction if it is exothermic. And the solution will gain heat. That is, the liquid will become hot because the reaction is happening in the liquid itself, right? All the reactants have been added to the liquid. So after some time, the temperature will rise and the solution will become hotter, as a result of which the thermometer will show you a rise in temperature. So heat released by the reaction is nothing but the heat gained by the solution, and then you can calculate. Very, very important point, because the pressure is constant, I will say here the heat is equal to change in enthalpy of reaction, that is delta H. Okay. So now we need to know the calculations related to the next type of calorimeter, which is constant volume calorimeter. This is frequently asked in the exam, so you must know. Now, what happens here is you have to just know briefly regarding the construction, not fully. I have written in detail, but let's not get into the depth right now. Just focus on the diagram now. Okay, now this is called a bomb. This rectangle, small rectangle which I've shown or placed here is called a bomb. This one. It's usually made of steel. This is called a bomb. Inside the bomb, I have placed my fuel. What fuel? Whatever substance whose combustion reaction is to be studied is called a fuel. It could be carbon, it could be naphthalene, it could be benzoic acid, it could be glucose. That means any substance whose combustion reaction will take place inside this bomb is called a fuel. The fuel is placed inside the bomb, and the bomb is made of steel. Because the fuel is placed inside the bomb, I will say that it is a constant volume system, because the bomb is having a fixed volume. It cannot expand or contract. It is a closed container, right? So that is called a bomb, and the bomb is closed. Since the bomb is sealed, it is called a constant volume system. The bomb contains the fuel. Now, the bomb has wires, which you see, and these wires are externally connected to a circuit so that I can pass current. Why do I want to pass current? I want to pass current in order to start the ignition. To start the ignition, I need to pass current, because source of ignition is nothing but the current here, or the spark which is generated. If I want to cause a spark, I will use some source of ignition. Like if you want to light a matchstick, you rub it or you strike it against the surface of the matchbox. So it is similar to that. So your current is used to cause the spark. What is the reaction taking place inside the bomb? The reaction taking place inside the bomb is a combustion reaction, wherein oxygen gas reacts with the fuel present. So you see a supply of oxygen gas. So a connection for oxygen supply is shown. That connection for oxygen supply is directly connected to the bomb. The bomb contains fuel, the bomb contains oxygen gas. Both reactants are inside the bomb. And also, in order to start the ignition of the fuel, wires are connected to the fuel and current is passed through those wires. Now, outside the bomb, you see there's a huge shell. This is called huge material. This entire thing is called a box, or I can say it's a large shell, okay, or a vessel. This is a large vessel. This one. So this entire thing is a large vessel. That vessel contains water or any solution or liquid. Let's call it liquid also. Some books call it liquid. Either you call it solution or you call it liquid. The liquid may be water, usually it's water, but I'm not writing water because sometimes it can be something else also. Usually it is water. At times it could be something different. Right. So just in order to maintain the general term, I'm using solution as a term, or I'm using liquid as a term. This liquid is agitated with the help of a stirrer. You see a stirrer also placed inside the vessel. And the vessel is insulated. Like you see, I've shown the insulation. The vessel is insulated. Why? Because I do not want any flow of heat in or out. I do not want heat to enter the vessel from the surroundings, that is from the outside. Also, I do not want any heat to flow out of the vessel. That is why it is insulated. Now, when the reaction happens inside the bomb, the heat which is generated at constant volume. So I can say if volume is constant of the reaction or of the system, then delta U is equal to Q, because as per first law, delta U is equal to Q plus W. If volume is constant, W becomes 0. And I'll just say that delta U is equal to Q. So whatever heat I'm measuring in this calorimeter is nothing but a change in internal energy of the reaction. It is not delta H. It is delta U because the volume is constant. Why is the volume constant? Because the bomb is sealed. If any reaction takes place inside a closed container or a closed bomb or a closed vessel, remember that the volume is constant and the work done is 0. So delta U will be equal to Q in this case. Now what happens is, once this heat is released, because any combustion reaction is exothermic, so heat will be released. Once this heat is released after the reaction is over, this entire heat is passed on to the water, because this entire bomb is placed inside the vessel containing water. So the water will absorb the heat which is released by the reaction. That means water is gaining heat. So the reaction produces heat because it's exothermic, and the water gains heat which is produced because of the reaction. Whatever heat is absorbed by the water can be calculated by seeing a rise in the temperature, which is shown by the thermometer immersed in water. So here the principle again is same. That is, heat released by reaction is equal to heat gained by solution or liquid. Now calculations. This is the calculation. Let's understand this properly now. This is a calculation. We'll do 2 questions. I'll show you 2 questions now. Then you will understand. Q reaction plus Q calorimeter plus Q solution is equal to 0. This is the equation that you have to use for solving a question. Okay. Which is based on calorimeter. Now Q reaction will be negative because it's combustion. So I'll write here Q reaction is negative. Within bracket I'll write because of combustion. What is combustion? Combustion is a reaction where oxygen gas reacts with the substance. That means if Q is negative, heat is released, so it's exothermic. Any combustion reaction is exothermic. The calorimeter and the liquid both will absorb heat because the calorimeter itself is also made up of some material, right? So even that will absorb some heat. That is why I'm saying Q calorimeter and Q solution are positive values. Q calorimeter is calculated in this way. C cal into delta T. What is C cal? C cal is calorimeter constant that depends on the material of the calorimeter. Also called heat capacity of calorimeter. And what is Q solution? MC dt. What is M? Mass of solution. C solution is specific heat capacity of liquid. That is joule per kilogram Kelvin or joule per gram Kelvin. Once we have put these values, we can get the value of Q reaction. And finally, one more thing you have to understand. If in the question they ask you to calculate the enthalpy of combustion, that means they want you to find out delta H. Now, this is a constant volume calorimeter. So what you have found out as Q reaction is delta U, not delta H. Because in constant volume system, Q is nothing but delta U. So whatever Q I have written here, this Q reaction, this is nothing but what? This is delta U. So this is delta U of reaction. So in a bomb calorimeter, we can measure delta U. We cannot measure delta H. Why? Because the volume is constant, and if volume is constant, Q is same as delta U because work done is zero. Q is equal to delta U if volume is constant. So I'm measuring delta U here. So Q solution here is, Q reaction here is delta U. But I may calculate the value of delta H by using this formula which we have learned today. Delta H is equal to delta U plus delta Ng RT. Put the value of delta U, put the value of delta Ng, put the value of R, put the value of T, I get delta H. So I can calculate the value of delta H by finding out delta U. That means I'm measuring delta U in the calorimeter, but eventually I can find out the value of delta H by using the formula. So whatever is being measured is delta U, and using that value which has been measured, I can finally find out the value of delta H. Very, very important points under note. If Ccal is not given or Ccal is not asked for, then put Ccal equal to 0. That means what? The value of calorimeter constant is not given to you, let's say. The Ccal is not given. If it is not given, or if they have not asked you to find out the value of Ccal, simply put that equal to 0. Similarly, if C solution is not given, or also they have not asked for it, put C solution equal to 0. Units of Ccal at joule per Kelvin. Now remember, this is calorimeter constant. Calorimeter constant depends on the material of the calorimeter, not on the mass of calorimeter. So the unit of Ccal will be joule per Kelvin. Don't say joule per gram Kelvin now. Why? Because calorimeter material is just going to decide the value of Ccal. Mass of calorimeter has got nothing to do with this. Okay. Let's look at this question. Bomb calorimeter has been given. Temperature is 25 degrees Celsius before the reaction. Now remember, whatever is the temperature before the reaction is nothing but the temperature of the reaction. That means reaction happens at that temperature. Calorimeter constant is given. Heat capacity of calorimeter is given to you. So C cal is given. And as I said, joule per Kelvin is same as joule per degree Celsius. Why? Because change in Kelvin is same as change in degree Celsius. Delta T, that is change. Delta T, that is change in temperature, is same whether you take Kelvin or you take degree Celsius. So I can say joule per Kelvin is same as joule per degree Celsius. Calculate the molar enthalpy of combustion of benzoic acid. Fine. Enthalpy has been asked. That means we have to use delta H. Enthalpy is what? H. So molar enthalpy of combustion will be delta H. Molar means for 1 mole. But before that, I need to use the equations pertaining to the calorimeter calculations. So this is the first thing which I have to use. That is this formula. So I will use this formula. In the question, C solution is not given. They have not mentioned specific heat capacity of solution or liquid. So I can take C solution as 0. If C solution is not given or not asked for, put C solution equal to 0. Okay. How many grams? 12.2 grams of benzoic acid. Grams by molar mass is moles. What is benzoic acid? We have learnt in IUPAC nomenclature that this is benzoic acid. Right? Also, you write like this. This is benzoic acid. So if I find out the molar mass, it will be 122. Grams by molar mass is moles. So 0.1 moles of benzoic acid have been used in the reaction. Now put this Q reaction plus Q calorimeter plus Q solution equal to 0. Since C solution is not given, I'll take C solution equal to 0. If I take C solution equal to 0, then this entire term will become 0 because Q solution is what? Mass of solution into C solution into delta T. C solution is 0, so this entire term will vanish. This will be the final equation. C cal is given, final temperature minus initial temperature is delta T. From this, I can calculate the value of Q reaction. But what is Q reaction in bomb calorimeter? That is delta U. Q reaction is delta U. Now, this is the value of delta U when 0.1 moles of benzoic acid have been burnt. So if 1 mole of benzoic acid is burnt, then I'll get the value as minus 25,000 joule per mole. Why? This value is for 0.1 moles, right? Initially we found out that there are 0.1 moles of benzoic acid. So I can say if 0.1 moles are burned, then 2500 joules is the value, minus 2500 joules is the value of delta U. So if 1 mole is burned, then X joules will be the value of delta U. Cross multiply and we will get the value of X as minus 25,000. So I can say that delta U is minus 25,000 joule per mole. Now, they have asked me enthalpy of combustion. That means now they want me to find out delta H That is, now for delta H, I'll use this equation, this reaction. Combustion reaction is always with oxygen gas. Question has mentioned that benzoic acid is solid. So I have written S. S stands for solid. Remember that if any compound contains carbon and hydrogen, then the products of combustion are always carbon dioxide and water. So the products in this reaction are CO2 gas and H2O liquid. Always take water as a liquid in combustion reaction, unless they mention something else. Always take water to be in liquid form in any combustion reaction unless mentioned otherwise in the question. Delta Ng is this 7 minus 15 upon 2 minus 0.5. Because solids and liquids are not taken into consideration for calculating delta Ng. Now I can put the values. Temperature of reaction is 25 degrees Celsius. 25 degrees Celsius. Whatever is the initial reaction corresponds to the temperature of reaction. But 298 Kelvin is the value of temperature because I cannot use 25. I have to convert it to Kelvin. So finally, I'll get this. I'm solving. If I want to convert it to kilojoules per mole, then I can divide by 1000. So this will be the final answer. Molar enthalpy of combustion. So enthalpy is what? Delta H. This next question is also of a similar kind. It is solved. You can go through it. Complete the notes of today's lecture as well as of the previous lecture and submit before Monday. Okay, thank you.